right, this is our last review video, the last video you'll watch this year. We're going to finish off review sheet 4. We're going to do together numbers 8, 10, 12, and 17. Now, number 8, it doesn't say it there, but we're going to do 8 just as a setup. Any of the other ones, it tells you if you're doing just a setup. So 16 is going to be just a setup, and 17 is going to be just a setup. So we'll start with number 8. So we want to find the length between, or the length of the curve. Arc length, you do derivative squared plus 1 and put it all under a square root in your integral. So first we want to put this in a form that's easier to take the derivative. So we'll write it as 1/6 x cubed plus 1/2 x to the negative 1. We'll now take the derivative. It'll give us 3/6, which is really 1/2 x to the second. We'll have negative 1/2 x to the negative 2. And we'll have that squared plus 1 under our radical. So we'll go 1/2 to 2. So if it's a setup one, don't go do too crazy neatening it up. If you have to do it all the way through, you would want to square anything out. You have to square out, add the 1, and then often this becomes a U substitution case if it's one you have to do all the way out. And you'll see that in the next 3 and 9, 10, and 11, I believe. And we'll see one of those together. But 8 we're going to do just as a setup, and that would be it. So we're going to go on to number 10 next. So we want to find the surface area. So it's radius and then 2 pi radius and then times the arc length. So square root of derivative squared plus 1. So let's go ahead and do our derivative. If we square that and add 1 squared, we would get 9x to the 4th and then plus 1. So we're going to have 2 pi, the integral from 0 to 1. We'll come back for our radius in a second. And under the radical, we'll have 9x to the 4th plus 1 with a dx on the end. Remember, surface area and arc length can be done dx or dy. It does not matter. Usually, however, it's given to you in your interval is what you tend to do. Okay, so our radius. So here's an xy axis. We are going over the x-axis. That's a vertical line attached to the x-axis. We always think of that as y, but we can't put y in because it's dx. So we've got to put in x cubed. Another way you can think of it to get the radius is, okay, this length here, we got to do top, whatever the top minus the bottom is. The top edge will be whatever this function is, and the bottom edge will be the x-axis, which is y equals 0. So it's kind of like we have an x cubed minus 0. You could think of it that way too. All right, we don't have a plate on x under our radical, so we've got to do a u substitution. du is 36x cubed dx. So this part's taken care of. That's going to be square root of u. Our leftover is x cubed dx. So we've got to multiply by 1 over 36 to get that to match up. So the 1 over 36 will multiply with the 2 pi, and that'll just give us pi over 18 out front. The x cubed and the dx was the 1 over 36 and the du. And we have square root of u, which I'm going to write as u to the 1/2. So this will become u to the 3/2, and we'll have 2/3 out front, as well as the pi over 18. And we're going from 0 to 1. Now remember, you still have to replace u with what it's equal to. So if we do this 2/3 times pi over 18, you can take a 2 out of the top and the bottom. So this would become pi over 27. U is 9x to the fourth plus 1. And then we're to the 3 halves. From 0 to 1. So this is pi over 27. When we sub in 1, we'll get 1 to the fourth is 1, times 9 is 9, plus 1 is 10, so we'll get 10 to the 3 halves. And we can't make that any nicer, we'll leave it at b. Minus, when you sub into 0, we just get 1 to the 3 halves, which is 1. And that's our final answer. All right, we're going to look at number 12 next, which is an average value one. Average value, you just do 1 over b minus a, and then integral of the function. So we're going to have 1 over 4 minus 1. We'll have an integral from 1 to 4, and our function will have 3x squared minus 2x dx. So we will have 1/3. When we do our antiderivative, we'll have x cubed minus x squared from 1 to 4. Subbing 4 in, we'll get 64 minus 16, minus start a parenthesis. We'll have 1 minus 1. So those wipe out. 64 minus 16 is 48. 48 times a third is just 16. So the average value of this function on the interval is 16. What that means is if you took the graph and imagine there was sand underneath, and you shook the sand and leveled it off on the interval, it would level off at a height of 16. All right, and the last one we're going to look at is number 17. So we have this inverted cone here. Usually when you have a cone, when you draw your xy axis, you put the point of the cone at the origin. Oops. So we have an inverted cone. It's filled with water to a height of 8 meters. The radius of the base is 4 meters. So we know this is 4. And the height of the cone is 10. So this is 10. But keep in mind, we're only filling it up to 8. Find the amount of work done to pump all the water out through a hole in the top. Density of the water is 100 or 1,000 kilograms per meter cubed. Acceleration due to gravity is 9.8 meters per second squared. So if you are in metric, which this is, you just have to multiply that by that 9.8. Okay, if we're in pounds, we don't have to worry about that. So we got that 1,000 times 9.8. Now we got to do times the volume of a slice. Well, our slices here are all going to be circles. So we got pi times some radius squared, and then dy is our thickness that turns it into a volume. Well, let's call this x. This would be y, and a common technique in cones is to do a proportion. So x over 4 is equal to y over 10. And this slice that we did, its radius of that circle of the slice is the x. So we would want x to go in here, but we have to be in terms of y. So if you multiply the 4 over, we get 4/10 y, or in other words, that's 2/5 y. And then we have to do the distance. Well, our distance that we would travel is this length here. It starts out as 10, and we're chopping off y, so we would want 10 minus y for our distance. So we've just got to put this all in our integral. Any constants can go out front. So 1,000 times 9.8, that'll move the decimal over 3 places. That's 9,800. We got a pi. 2/5 squared will give us 4/25. So we can put that out front. We'll have our integral, and we're going to have y squared 10 minus y dy. And then on our integral is where the slices could occur. Well, the lowest the slice could be is 0. The highest would be 8 because the water is only 8 high. The cone was not filled all the way. Now this is actually an antiderivative we could do pretty easily. You could distribute it, do your antiderivative, and go from there. But all it asked us for was to set it up. So that's it. So most of the ones we saw were not in metric, so you did not have to multiply by the 9.8. I think the other ones that you have to do are all in pounds. Yes, looks like they're in pounds, so you won't have to multiply by that 9.8. You'll just start with your density, do the volume of the slice, and then times the distance. And that's it for video 12.